In a series circuit, components are in a single loop. Electrical components are connected one after the other in a single loop. Current is the same everywhere. Voltage is shared across components. Let's look at this simple series circuit. Notice how everything is connected in one continuous loop, from the battery through each component and back again. We have two ammeter symbols labeled with a capital A, and they both show 5 amps. That's the key rule in a series circuit. Current stays the same at all points in the circuit. It doesn't change as it passes through the lamps or the wires. We also have 2 bulbs. Each one is labeled 5A, meaning that 5 amps of current is flowing through them too. So remember, current is same everywhere in series circuit. Let's take a closer look at voltage in a series circuit. In this diagram, you can see a battery supplying a total of 6 volts. There are 2 bulbs connected in series, and we've placed voltmeters around the circuit to measure how much electrical potential energy, or voltage, is being used. The voltmeter at the top reads 6 volts, which is the total voltage supplied by the battery. But check this out. Each bulb has a voltmeter next to it showing 3 volts. That means the total voltage is being shared between the components, so 6 volts get split into 3 volts for each bulb. So in summary, voltage splits across components. The total voltage adds up to the battery's supply. Each component uses a share of the energy. All right, let's zoom in on this final diagram, the parallel circuit. This one's super important to understand, especially for your exams and real-life applications like house wiring. First, notice the structure. The battery at the top sends current out, but instead of one loop, the current splits into multiple branches. Each bulb is on its own separate loop. That's the magic of a parallel circuit. The arrows show how the current splits to go through each bulb independently and then rejoins at the bottom. This means each bulb gets a direct path to and from the battery. If one bulb goes out, the others keep working because their paths are independent. And here's the rule you must remember. In a parallel circuit, voltage stays the same across all components. Each bulb gets the full voltage from the battery. Current splits between branches depending on the number of components and their resistance. Let's take a look at this parallel circuit example. You can see that the circuit has 2 bulbs, and each one is on its own separate loop or branch. Now look at the ammeter readings. At the top, where the battery is supplying current, we have 4 amps going into the circuit and 4 amps coming back. That's our total current. But when the current reaches the branching point, it splits evenly. One loop sends 2 amps through the top bulb. The other loop sends 2 amps through the bottom bulb. That's because both branches have the same resistance, so the current divides equally. The total current is shared between the branches. Each loop gets part of the total current based on its needs. So here, 2A plus 2A equals 4A, it all adds up. Here we've got a battery supplying 6 volts, and there are 2 bulbs, each on their own separate branch of the circuit. Notice the voltmeters. The one across the battery reads 6. That's our total supply. Each bulb has its own voltmeter, and they also read 6